So this is a standard single-channel measurement demo where we will use the new cross-correlation feature of the FSWX to reduce measurement uncertainty. So for this demo, I have a very simple setup. A very small in power signal is going from the vector signal generator directly into port A of the FSWX. My spectrum plot, this time I chose to use 19 GHz, and I have configured a standard RMS detector for the beginning, shows a straight line, which is basically just wideband noise. It seems there is no signal present. However, when I activate cross-correlation again on a second trace, just by selecting the cross-correlation detector on trace number 2, we can see trace number 2 in blue building up, and when it builds up, we can definitely see a modulated signal peeking out of the remaining noise floor. What I want to highlight in this example is, with cross-correlation, there is almost no limit in how much improvement in noise floor you get. The only price you pay is basically the sweep time. So I have configured 20 milliseconds as the sweep time here, and as you can see, my headline shows me 10,000 cross-correlations, which translates directly into around 20 dB of improvement. And when I reduce that, you can see the noise of the cross-correlation trace going up. And at the same time, the measurement speed is significantly increasing. So you can choose how much down you want to go in noise floor and in noise contribution from the instrument, at which price. Because as always in life, for each feature you get, there is a price attached, and this time for unlimited dynamic range, the price is unlimited measurement time. However, the trade-off is flexible. You can pick the sweet spot for your application. So by using the cross-correlation detector, we have reduced measurement uncertainty, and we again can show significantly better results for your device under test.